So now here's another example. Suppose I have one d4 and one d6. What does it mean? I've tossed one 4-sided die and I tossed one 6-sided die. So question, what is the probability that the sum is 5? So this is the same as asking for the coefficient of x5 in this polynomial. So this is the polynomial of the 4-sided die. That means the output will be 1, 2, 3, 4. This is the polynomial for the 6-sided die. That means the output will be 1, 2, 3, 4, 5, 6. So this should be 6. And then you multiply them. So if you multiply them, this table gives you all the possible output of the product between these two polynomials, and this is the sum. So that means what? If I multiply these two things, again, this should be a 6, then I will get this thing. So what's the coefficient of x5 here? The coefficient of x5 here is 4, okay? So basically it's 1 of them, 2 of them, 3 of them, 4 of them, so 4 of them. So how many possible ways can you have in 1d6 and 1d4? Product rule. For 1d4, it's 4-sided die, so you have 4 choices. 1d6 is 6-sided die, you have 6 choices, so 24 choices. 4 out of these 24 choices have sum 5. So that means the probability is 1 over 6. So here is another example. So suppose you toss a coin and a 4-sided die. And here's a funny rule. If the coin gives you 0, then we ignore the die and take value 0. And if the coin gives you a 1, then we take whatever value the die gives us. What's the probability you get a 3? So we can do it by brute force. So if we do it by brute force, so this is the sample space. So the first thing in this ordered pair is the output of the coin. The second number is the output of the die. So it will be tail 1, tail 2, tail 3, tail 4, head 1, head 2, head 3, head 4. How many elements? 8 of them. So what's the event we are asking for? The event is we get a value 3. Because of the rule, we only get value 3 if the coin gives us a head. So the event set is the order pair 1, 3. So that means coin is head, the die is 3. How many elements are there? 1. So what's the probability? Probability is defined as the set E cardinality divided by the set omega cardinality. That means 1 divided by 8. Consider by product rule. The product rule will be there's half chance we can get head and 1 over 4 chance we can get a 3 in the 4-sided die. So therefore it will be this number multiply this number, which gives us 1 over 8. And here's a question for you. How do you solve this problem using generating function? Think about it. Here's another set of example that combinatorics is useful in probability. Suppose you flip a coin 5 times. This coin is fair. What's the probability of getting 3 head? The number of ways you get 3 head is 5 choose 3, so that's 10. The number of all possible outcome is the size of the sample space, which is 2 to the power 5, which is 32. So the probability of toss 5 coin give you 3 heads is just the size of the event divided by size of the sample space, so this. What's the probability of getting at least 3 heads? Well, the probability of toss 5 coin give you at least 3 heads means the probability of toss 5 coin get 3 heads or get 4 heads or get 5 heads. So this is the answer. So what's the probability of getting even number of heads in the 5 toss? So probability of even number of heads, that means you toss 5 get 2 heads, toss 5 get 4 heads, or toss 5 get 6 heads. Okay, just for fun, this guy is impossible because you toss 5, you cannot get 6 heads. So this guy is 0, okay? This guy is 0, okay? So you have what? The number of Ks you can get 2 heads in the 5 toss plus the number of Ks you can get 4 heads in the 5 toss divided by all the possible number of toss. So this is the answer, okay? So we are just talking about binomial theorem in combinatorics used in probability. So now what about trinomial? Well, actually football match is a trinomial probability. So for football, you have 3 outcomes. That is, you win a match, you lose a match, or you have a draw, okay? So suppose Manchester FC has a constant win rate of 0.5, constant lose rate of 0.2, and a constant draw rate of 0.3, regardless of what team they play against. Now suppose Manchester play 20 games, okay? What's the probability in this 20 game? Manchester get 10 win, 4 lose, and 6 draw. That means 20 game, choose 10 win, choose 4 lose, and choose 6 draw. This is multinomial trinomial coefficient. Multiplied by 0.5 is the win chance, power 10. 0.2 is the loss chance, power 4. And 0.3 is the draw chance, power 6. So it will be this number, which is about 0.044, okay? What's the probability of Manchester to get at least 19 win? Well, it will be 19 win, 1 lose, 0 draw, or 19 win, 0 lose, 1 draw, or 20 win, no lose, no draw, okay? So each of them is one possible way that this is true. So for 19 win, 1 lose, no draw, this is the probability. 19 win, 1 draw, no lose, this is the probability. And 20 all win, this is the probability. And again, this is wrong, this should be 20, okay? Then what about what's the probability of Manchester have at least 15 win? This will be a very complicated problem because 15 win, you have so many possibilities. If at least 15 win means you have at least 15 win, 16 win, 17 win, 18 win, 19 win, and 20 win. And then within this 15 win, you have different combination of draw and lose. So it can be what? For all the 5 not win cases are all lose, or 4 lose 1 draw, 3 lose 2 draw, 2 lose 3 draw, 1 lose 4 draw, or no lose all draw. So these are all the possible cases for 15 win. And you do the same for all the 16 win, and 17 win, 18 win, 19 win, 20 win, and then you have a bunch of number. You add all of them because this is disjointed case, so you can use sum rule. This is just an illustration. Usually this kind of thing, you need a computer to do that.